Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. Now in this lecture, we are going to study non-ferrous metals and alloys. In the previous lecture, we have seen what are the different types of materials available and how they are classified, and what are the different types of ferrous and non-ferrous metals. And in this lecture, we are going to see what are the non-ferrous metals that are available and how we can use them in engineering field. Now in the previous lecture, we have seen there are different types of aluminiums. So aluminum, when it is mixed with some other components like manganese or copper, we can form new types of alloys. Now in this, let us see what is manganese and how it can be added to aluminum to form a new alloy, that is duralumin. So manganese acts as a strengthening agent and prevents the formation of a coarse crystalline structure during heat treatment. Some of the important aluminum alloys are duralumin, which is, when we see the composition of duralumin, we can see aluminum constitutes about 94%, and copper is about 4%, and a very few percent of magnesium, manganese, silica, ferrous, etc. are present. So the key component that is added to aluminum is copper. So in this, copper is the key component that is added in order to improve the properties. Now if you see what are the properties that duralumin has here, it can be casted, forged and stamped. So all these processes can be easily done for duralumin. So this is the first property, and then it has high tensile strength. So when compared to regular aluminium, this duralumin has more tensile strength. So it can bear more tensile loads. And then the third point is it possesses high electrical conductance. So compared to the normal aluminium, that is not alloyed aluminium, this duralumin will have more electrical conductance. That means it can be used to make wires for electrical conduction, for transfer of electricity from substations to our domestic home purpose. So these wires can be prepared with duralumin. And then specific gravity is about 2.8 and specific heat is 0.214. So not only the properties like tensile strength and electrical conductance are improved, but the specific gravity is also developed here. So it can bear more load at less weight. And then the melting point of this duralumin is around 650 degrees centigrade, which is very near to the actual aluminium. And brittle hardness is about 60 in annealed and 100 for age-hardened aluminium. Okay, these are the properties of this duralumin. Now, let us see what are the uses of duralumin, where it can be used. So, it is widely used for sheets, tubes, forgings, rivets, nuts, bolts and similar parts. So, these are the different parts or mechanical elements that can be prepared by using this alloy of aluminum called duralumin. So sheets can be prepared, tubes, forging, rivets can be prepared. So most of the rivets are made up of this duralumin, which is an alloy of aluminum, and then they can be used for manufacturing of nuts, bolts, etc. And these are also used in making cables because they have high electrical conductivity. They can be used to prepare cables also. So it is also extensively used for airplanes and other machines where weight is a deciding factor. So we have said earlier that aluminum, when compared to iron, it is very less weight because the specific gravity is very less. So in the place of iron, we can use aluminum or its alloy like duralumin, which can resist or which can bear the same load but at lesser weight. So while we are designing or manufacturing aerospace or aeroplane structures, we have to go for lighter weight materials just like duralumin. So this material is widely used in the aerospace industry. And the duralumin is also employed in surgical and orthopedic work and for non-magnetic and other instrument parts. So some other medical applications, like they can be used for orthopedic equipments, and they can be used for surgery, like these tools can be used to make surgery set. And for non-magnetic applications, whenever there is no magnetism is present, we can use this duralumin because it is not magnetic in nature. It is completely, it has conductivity, but it is not magnetic. And then we have second type of alloy for aluminum. This is called as Y alloy, where the composition goes like this. Aluminum is about 92.5% and copper is about 4%. Along with copper, we have nickel. Nickel is about 2% and magnesium is about 1.4% is added to this aluminum for getting some more important properties. So see here, the important properties of Y alloy are its strength at 200 degrees is better than aluminum. Even so, because of this property, this Y alloy can be used at higher temperatures like engines, internal combustion engines, and its body parts can be prepared or manufactured with Y alloy because its strength is higher than the aluminum at a temperature of 200 degrees centigrade. It retains its high strength and hardness at high temperature. It can be easily casted and hot work. So because of these properties, this Y alloy is widely used in automobile industry. And let us see what are the uses of this Y alloy. It is extensively used for such components as piston cylinder heads, crankcase of internal combustion engines. Mostly IC engines are made up of this Y alloy because it is lightweight yet similarly stronger as compared to iron. So it is also used for die casting, pump rods, and in sparking chisel in place of steel. So whenever we want to cast some objects, so we will use the die casting made up of Y alloy. So these are the applications where Y alloys are used, mostly in automobile related industry, where we are going to manufacture the engines. We are going to use Y alloy because it is very strong at high temperature. And then we have third type of alloy, that is hindallium. So this is a alloy of aluminum which is combined with magnesium, manganese, chromium and silicon. So these are the key components of this alloy, where magnesium, manganese, chromium, silicon, etc. These are all added to improve the actual properties. Okay. Now, whenever we see the name hindallium, so this hindallium is particularly developed by a industry named Hindustan Aluminium Corporation Limited. So this is located in Raincoat district, Mirzapur in Uttar Pradesh, India. Because this industry named Hindustan Aluminium Corporation Limited first manufactured or first found this composition. So this alloy is named after this organization, that is Hindallium. Okay. So it is manufactured as a rolled product mainly for anodized utensil manufacturing. Okay. So this hindallium is particularly used for making of the utensils which are used in homes, which can be used for cooking purpose. So during the process, a special care is taken to maintain the necessary mechanical and surface characteristics. So some particular characteristics while making this hindallium as an alloy, which is used to make utensils and etc. So to make utensils, we need to take more care in order to make the metal suitable for working at high temperatures, because while cooking we have to use the utensils at higher temperatures. So this metal or this alloy has to be very stable at higher temperatures. It should not melt or it should not release any kind of chemicals or composite make whatever the chemicals are there like magnesium, etc. They should not be released into the food because they may contaminate the food which we use. So that is why the Hindalim is processed by a special technique for making it more suitable for cooking. And then we have another non-ferrous metal, that is copper. So apart from aluminum, we have some other non-metals like copper, we have sodium, magnesium, etc. So all these can be comes under non-ferrous metals. And now let us see what is copper and how it is constituted and how it is obtained from ore. So copper, it occurs in some minerals such as copper glans. So copper glans is the one type of ore from which copper can be extracted. And then copper pyrites and malachites and azurites. So these are the different types of ores from which the copper can be extracted. So copper ores are found in Burma, Sikkim and Singhbum, Bihar. So these are the places in India where we can find the ores of copper, from where we can refine them and we can use for different purposes. So we all know copper is a very popular material which is used for electrical wiring because it can be drawn into very thin wires. It can be used for electrical conductivity. Okay, it has two good properties, that is, it can be drawn into thin wires and it has very high electrical conductance capacity. So because of these two properties, copper is used as conducting material for most of the electrical equipments. Even in electrical windings also, copper wires will be used. So refining is done to copper when it is in the blister stage. So whatever the ore we have obtained from Earth's crust, it is taken and it is refined. And this copper is 99% pure and further refined by oxidizing, which removes sulfur and other impurities. So the copper which is obtained from the ore is purified, and from this we can get 99% of a pure copper, and it is further oxidized to remove sulfur and impurities so that we will get purest form of copper. And then phosphorus, silicon, lithium, magnesium, beryllium or calcium are added to molten copper to eliminate the oxygen from making it more suitable for complex shapes. So in order to remove oxygen from copper alloy or the copper ore, we have to add some materials like phosphorus, silicon, lithium, magnesium, beryllium or calcium. So all these, any one of these elements can be added in order to remove the oxygen that is present in the copper, which makes it weaker or which makes it not suitable for making small sized objects. So this is another process which is done while the ore is refined. Arsenic in amounts of up to 5% is added to improve the strength and toughness of the metal. So arsenic is a metal which is added to copper to improve the properties like strength. Okay, and also the toughness of the metal can be increased when it is needed. So copper is combined with some kind of other metals like arsenic to form some types of alloys where they can be exhibiting new properties. So let us see some basic properties of normal copper, that is pure form of copper. So it is reddish brown metal. It has a reddish brown color. Copper is a very good conductor of electricity. We all know that. If copper is heated to red heat and cooled slowly, it becomes brittle. But if it is cooled readily, it is soft, malleable and tactile. So this is a very peculiar behavior of copper when compared to iron. Whereas iron, when it is rapidly cooled, it will become brittle. On the contrast, copper, when it is rapidly cooled, it will become more malleable and tactile. When it is cooled slowly, it will become brittle. So this is one peculiar property of copper. And the melting point of copper is about 1084 degrees centigrade, and boiling point is at 2595 degrees centigrade. So because of this high melting and boiling point temperatures, this copper can be used in electrical conductance where the temperatures, very high temperatures does not cause any harm to the copper. Okay. And then the specific gravity of the copper ranges from around 8.9 and electrical resistivity is about 1.682 micro ohms per centimeter. So this electrical resistivity value, which is very less, 1.682 micro ohms, because of this very less resistivity, copper can be widely used in electrical conductance, like they can be used for electrical wirings and windings. And then tensile strength varies from 300 to 470 meganewtons per square meter. So copper is not that strong as iron, but it has some tensile strength that is about 300 to 470 meganewtons. And it forms important alloys like bronze and gunmetal when combined with minerals, some other minerals. So these exhibit different properties compared to copper. So these bronze and gunmetal, these are mostly used in some other applications, like bronze is used in making of some kind of plates, and gunmetal can be used in the preparation of shells for bullets that are used for machine guns. And when we see the uses of copper, it is largely used in making electric cables and wires. All the electric machinery and appliances, everything, every electrical component we see around will contain some amount of copper or mostly copper. All the electrical wirings are completely made with windings, these copper windings, and also mostly the motors, DC motors, AC motors, etc. These are all winded with copper. So this is how copper is very much used in the industry of electricity, where it can produce a very good conductivity. And these are used in electroplating, electrotyping, or soldering iron bits. So these are some other extra applications of copper where they can be used for electroplating. That means like plating. We use this technique in we use gold items which are made up of a layer of gold made on copper articles. So this is called electroplating. So this is done with the help of a technique called electroplating. So this can also be used as a damp-proof material and for making alloys. Okay, so copper can be used as damp-proof material. And fourth one, it is used for sheeting, roofing, spouts, boilers, condensers, and other purposes where corrosion resistance with fair strength and flexibility is essential. Okay, this is a very good point where the copper can be particularly used in boilers. So in olden days, we used to have boilers made up of copper at our homes for boiling water. So nowadays they are not so frequently used because we got geysers which are made up of electrical wiring and all. That is all different condition. Where in the olden days we used to have copper boilers which will use coal for boiling the water, and these are made up of copper, purely copper, and they have very fair strength and flexibility. So because of all these applications, copper is widely used in not the load-bearing applications. Apart from the load-bearing applications, it can be used in applications like electricity conduction, and it can be used for machinery. All electrical machinery is made up of this copper. And that is all for this lecture. We will meet in the next lecture with remaining alloys of copper. And that is all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.